Discover ancient reservoirs. The future of hydrogen energy? Forget everything you thought you knew about clean energy. There's a hidden giant stirring beneath our feet that could change the game entirely. While solar panels and wind turbines dominate headlines, a revolutionary energy source lies dormant underground: natural hydrogen reservoirs. But here's where it gets controversial. What if we could tap into geological hydrogen formed over millions of years, instead of relying solely on electricity-hungry electrolysis? Recent research reveals these subterranean hydrogen pockets aren't just scientific curiosities. They could massively outperform conventional energy reserves in both scale and global distribution. Geological surveys have identified abundant hydrogen trapped in rock formations like peridotite systems, crystalline basements, and sedimentary basins. Unlike finite fossil fuels, this hydrogen regenerates continuously through natural water-rock reactions, particularly involving iron-rich minerals. This self-replenishing quality means these reservoirs behave more like renewable assets than depleting wells, offering potential long-term supply security. And this is the part most people miss. The extraction process avoids energy-intensive electrolysis, leaning instead on straightforward drilling and gas separation techniques that could drastically lower production costs. Pioneering exploration companies are now mapping these elusive reserves using seismic imaging, aerial magnetic surveys, and downhole geochemistry. Early test wells show remarkable promise. Some sites produce over 300 cubic meters of hydrogen daily, with near-zero greenhouse byproducts. For perspective, that's pipeline-ready fuel surfacing directly from the ground. The geographical spread is equally compelling. From Africa's cratonic shields to Canada's bedrock and sedimentary basins across Europe and Asia. This global distribution contrasts sharply with geographically concentrated resources like lithium, potentially sidestepping political and environmental bottlenecks that plague other green technologies. The existing infrastructure advantage is undeniable. After extraction, gas simply passes through separation units to remove moisture and impurities. Current natural gas facilities can be retrofitted for this purpose, minimizing capital investment. As energy grids evolve to handle renewable fluctuations, these steady hydrogen wells could provide vital grid stability, a constant counterbalance to solar/wind intermittency. Now here's the contentious angle. Could natural hydrogen undermine the economic case for electrolysis-based green hydrogen? The numbers suggest yes. Even modest flow rate improvements could tip commercial viability given hydrogen's applications in transport, manufacturing, and power generation. What's your take? Should we prioritize geological hydrogen over electrolysis? Sound off below. Investors should monitor two critical developments: regulatory frameworks adapting to this nascent resource, and drilling innovations boosting well productivity. Strategic alliances between drillers, tech providers, and distribution networks will determine whether this becomes mainstream. Leading this frontier is Thor Energy, LON, focusing exploration efforts on South Australia's promising hydrogen-helium formations. One thing's certain: the energy transition just got a fascinating new contender that challenges our clean energy assumptions. Are we witnessing the birth of a hydrogen revolution or geological wishful thinking? You decide. Hope for humanity: the underground hydrogen revolution. What if the future of clean energy isn't soaring above us, in the sun or spitting through the wind, but waiting, quietly, deep below our feet? This bold idea could rattle everything we thought we knew about where our next great power source might come from. Imagine, while the world's attention is fixed on solar arrays and sweeping wind farms, a silent energy giant may have been hiding in the darkness beneath our shoes all along. Here's where it gets controversial. Until recently, the blueprint for sustainable energy seemed clear: harness more sunlight, build bigger batteries, master the hydrogen economy. But despite progress, producing hydrogen, long hailed as the ultimate clean fuel, still means expensive factories, tons of electricity, and, often, disappointingly high carbon emissions. It's almost ironic. In our relentless search for the cleanest energy, we may have been looking in the wrong direction. But this could change everything. Deep in an Albanian mine, a team of global researchers stumbled upon something truly remarkable: a natural spring bubbling with nearly pure hydrogen gas. And not just a trickle. Estimates suggest over 200 metric tons of this energy-rich element emerge each year, making it the largest known natural hydrogen seep on Earth. Pause for a moment. This isn't just another strange geological phenomenon to marvel at. It's the tip of a new energy revolution. Here's the part most people miss. This hydrogen isn't generated through man-made processes or costly reactions. It's naturally formed and trapped underground, possibly created over millions of years in the restless geology below. Scientists drilling through fault zones in the Balkans region have found the gas releasing in specific pockets, practically ready to use. This isn't theory. This is nature's own hydrogen factory, finally coming to light. Of course, before we get swept up in the excitement, there are real concerns, some that are bound to spark heated debate. For one, natural hydrogen gathers incredibly slowly, over vast timescales, only to be potentially drained in a matter of years. Does this really count as sustainable? And here's another twist. These hidden underground zones are home to bizarre, little understood life forms, and disrupting their habitat could destroy entire ecosystems we're only just beginning to discover. Then, there's a pragmatic question. Even these 200 tons a year are tiny compared to the staggering 100 million tons of hydrogen the world uses annually. So, is this a solution or just a distraction? Yet, the broader importance isn't in the numbers, but in what this changes about our scientific understanding. For the first time, experts have managed to precisely map and analyze how such hydrogen reserves form and persist, hinting at even richer deposits elsewhere. This revelation challenges our basic assumptions. Should we now dedicate more resources to searching the world's hidden layers for clean energy? Or does the risk of environmental damage and the hard truth that these stores aren't quickly replenished outweigh the benefits? Could this discovery safely complement the tens of thousands of tons of green hydrogen produced underwater elsewhere in Europe, or will it ignite another gold rush that puts fragile underground worlds in jeopardy? And this is the part that could really divide opinions. Are we about to repeat the mistakes of reckless oil drilling, this time in the name of hydrogen? Tell us what you think. Is deep earth hydrogen worth exploring as a potential climate solution, or does the environmental gamble make it a path we should avoid at all costs? Sound off with your take in the comments. Let's see where the real energy revolution starts. Shocking discovery. Natural hydrogen reserves hidden under mountains could fuel a cleaner future. Imagine a world where the solution to our energy crisis has been hidden beneath our feet all along. Scientists have recently uncovered massive reserves of clean fuel, natural hydrogen, buried deep within mountain ranges, a discovery that could revolutionize the way we power our planet. But here's where it gets controversial. Could this be the game changer we've been waiting for, or are we overlooking potential pitfalls? Let's dive in. In a nutshell, *glow showing Europe-Africa researchers have identified vast deposits of natural hydrogen beneath mountain chains, offering a promising alternative to fossil fuels. Mount Fuji. The geological process of serpentinization, common in mountainous regions, is key to the formation of this clean fuel. Magnifying glass tilted left exploration efforts in ranges like the Pyrenees and Alps are underway to map and assess these hydrogen reserves. Wrench. Overcoming extraction challenges and building infrastructure are critical steps toward making natural hydrogen a viable energy source. In the global pursuit of sustainable energy, hydrogen has emerged as a frontrunner, thanks to its clean burning properties and abundance. However, its production has long been hindered by high costs and reliance on fossil fuels. A groundbreaking study now reveals that mountain ranges may hold the key to unlocking vast, untapped reserves of natural hydrogen. This discovery could redefine our energy landscape, offering a cleaner and more accessible fuel source for future generations. The birth of natural hydrogen. Natural hydrogen, often called white hydrogen, is primarily formed through serpentinization, a geological process where iron-rich mantle rocks called peridotites react with water. This reaction produces serpentine minerals and releases hydrogen gas. Mountain ranges, with their unique tectonic activity, are ideal environments for this process. When tectonic plates collide, mantle rocks are pushed closer to the Earth's surface, where they interact with water. The fractures and faults in mountains further enhance water circulation, accelerating serpentinization. This makes mountain chains prime candidates for natural hydrogen reserves. It's essential to distinguish natural hydrogen from its counterparts. Gray hydrogen, derived from fossil fuels, contributes to greenhouse gas emissions, while green hydrogen, produced using renewable energy, is clean but expensive. Natural hydrogen, if harnessed sustainably, could offer a cost-effective and eco-friendly alternative, bridging the gap between gray and green hydrogen. A hidden energy treasure trove. The abundance of mantle rocks in mountain ranges suggests a significant potential for natural hydrogen production. Unlike deep-sea reserves, which are costly and complex to extract, mountain reserves may be more accessible. However, accurately assessing these reserves requires further research. Exploration projects in the Pyrenees, Alps, and Balkans are already yielding promising results, with signs of natural hydrogen production detected. These efforts aim to identify deposits and develop eco-friendly extraction methods. If successful, this could mark a turning point in the transition to sustainable energy. Challenges and opportunities. While the potential of natural hydrogen is immense, its path to commercialization is fraught with challenges. Locating deposits deep within the Earth's crust requires advanced exploration techniques, and extraction methods must be optimized for sustainability and profitability. Additionally, building infrastructure for storage and transportation is crucial. Despite these hurdles, the benefits of natural hydrogen, cleaner, potentially